Welcome to math task number 23A. So we've been working with expressions. Now we're going to work with an equation. An equation is a statement that says two expressions are equal, hence the word equation, right? Now remember, the expressions were like things like x plus 5 or y plus -2. They did not have equal signs, right? Sometimes I might have told you that y equals -2 and w equals 7. You had to evaluate. But the equation will have an equal sign. That's the big difference, right? So x plus 3 equals 1, right? Basically, you're just saying what number plus 3 gives me 1. And that's what we're going to be doing. We're going to be actually solving for x. The answer to an equation is a solution. And the easy way to see if your solution is true is just to plug in. So like, for instance, if I said x equals 3 in 5x minus 3, well, if I plug in 3 here, I get 5 times 3 is 15. 15 minus 3, that's 12. 12 doesn't equal 10, so 3 is not a solution. And on the flip side, if I said x equals -2, and I plug in -2 here, I get 12 minus 4 times -2, or -4 times -2. I get 12 plus 8, does 20 equal 20? Yes, it is a solution, right? So if you get a true statement, you know your answer is correct. Now let's draw a little figure up here at the top. Equations are like balance beams. You think about the equal sign in the middle, and whatever I have on one side, say I have 8, and I have x plus 5 on the other side, well, whatever this x is has to keep this equation balanced. So for instance, if I put 4 over here, well, I have 9 now on this side and 8 on this side. That equation is not balanced. But if I put 3 right here, I have 8 on this side, because 3 plus 5 is 8, and this equation is balanced. So you want to keep your equation balanced. So how do we do that? In order to solve an equation, we must isolate the variable, basically get it so that the variable is just left on one side, and keep each side of the equation balanced. We do that by using inverse operations to move terms from one side to another. The thought of inverse operation is the opposite of what we see, or the undoing of operations. So what do I mean by that? So if I see addition, the opposite of that is subtraction. The inverse of addition is subtraction. If I see subtraction, the inverse of that is addition. If I see multiplication, the inverse of multiplication is division. And if I see division, you thought of it, the inverse of division is multiplication. All right? So the key things to remember is I always want to isolate the variable, and then whatever I do to one side, I have to do to the other side, because that's going to keep my equation balanced. So let's start off with a couple of problems here. So here I have 4x equals 16. Remember, a number next to a variable means that we are multiplying. So I see multiplication. So therefore, using inverse operations, I'm going to divide. I'm going to always work with the side that has the variable. In this case, the left side has the variable. So I'm going to divide by 4. Making a fraction is the same as doing division. Now watch what happens. 4x over 4. Well, what's 4 divided by 4? That's just 1, and 1 times x is x. So x equals 16 divided by 4 is 4. Let's check our solution, right? If I plug in my solution into the original equation, what's 4 times 4? Well, it's 16. Does 16 equal 16? Yes, it does. Therefore, my solution is correct. Right? Pretend I got 5 here for some reason. Is 4 times 5 equal to 16? No, it equals 20. Therefore, my solution would have been incorrect. So I could have gone back and reworked it. Let's look at this problem. I see addition. So therefore, I'm going to subtract. So I have x plus 9 equals 13. Always work the side with the variable. That's this side. And so I'm going to subtract 9 from both sides. Both sides, I mean, is this equal sign. Sometimes it helps draw that line right there. 9 minus 9 is 0. I don't write 0. I just cross them off. I drop down my x. X is equal to 13 minus 9 is 4. Let's check this solution by plugging it back in. 4 plus 9, that's 13. 13 equals 13. I have a correct answer. Right. Notice it wouldn't make any sense in this problem to bring 13 over to this side, because in doing that, I'd get 9 plus 13, which would be 24, and 24 plus 9 is not equal to 13. Right? So you always want to move the terms away from the variable. Let's do another one. So here I see subtraction on the left side, x minus 8. So therefore I'm going to add to both sides. So again, it's helpful to maybe just draw this scale right there. And that will let you know, okay, it makes more sense to add 8 to both sides. And you might be saying, wait a minute, Mr. Mason, 8 plus 8, that's not 0. Well, again, you think of this as negative 8 because you saw subtraction, right? So negative 8 plus 8 is 0, right? Don't write the 0. You have to cross them off. Drop down your variable, and 14 plus 8 is 22. Let's check it. 22 minus 8, or 22 plus negative 8, same thing, is equal to 14. 14 equals 14. You got the correct answer. All right, we'll try more in partners. Good luck.